Good evening, everyone. My name is Jyoti Sharma, and this is week 4. So we will start. This is the time that we will start from 7 to 9. So let's. So first, am I audible or not? Can you please confirm me quickly so that we can go fast?
Yes, ma'am.
Okay. Thank you so much. So what we will do today, we have from lectures 16 to 20, we do have 5 lectures, right? And 5 lectures are basically on sampling and the analysis. So for example, if we want to sample the air, or for example, if we want to collect the air and we want to see different contaminants or pollutant in the air, so what we have to do is we have to collect it, right? So the collection is somewhat in the layman language, we can say we will do the sampling, right? Then after that sampling, we will have that sample, and after that sample, what we will do, we will analyze it, right? So the thing is, we have to analyze, we have to sample, right? So we will try to cover today air sampling and analysis, then water sampling and analysis, and then we will touch somewhat about the soil and even the solid waste analysis, and again the sampling part. The first part, if you can see here, this part is related to the air. So we will see how we can sample the air, and then what different methods of the sampling we have, and air we have, like some pollutant are coming from the chimneys as well, right? So this will come under the stack sampling. Then we have to analyze that gas component, so this is the part of air. Then we will touch somewhat about the water, so this is the part of water. We have to sample the water, we have to do the sampling, then measurement, and measurement of different parameters, right? So for example, if we do have different metals in the water, if we have organic carbon in the matter, organic carbon in the water, so we have to do is the measurement. So this is the water part. Then this is the soil, or you can say the solid part. Again, what we will do, we will do the sampling, we will collect that soil, and we will see what different contaminants or pollutant we have in the soil. So this is all about the sampling and the analysis. Then what we have next is, we also have some rules and regulation that CPCB and even environment ministry has formulated related to the environment. So for example, it is air act or water act or environment act. I don't think that I have today question about this, because these are just like you have to learn these things, you do not need to understand much, so I didn't touch yet about these rules and facts and acts. But if you will allow me, then I can give you in the next lecture. Okay, so we are starting with the air sampling and analysis. So what I have, I do have same like week 1, 2, and 3. I do have a lot of MCQs question. We will do the discussion. You will tell me the answer. You can write in the chat box. Even you can speak whenever you want to. And please don't afraid whenever you are giving wrong answer as well, because that will make concept more clear to you, because I will give you some explanation why this is not the right answer, why this one is the right answer. So I encourage you to please speak, communicate, or write in the chat box whenever we do have a list of MCQs, right? So now we are starting with air sampling and analysis. If you do have any problem, if my speed is fast, slow, you can write me and I will try to improve this, right? Okay. So, okay, this is the brief discussion that what we are doing today is that we do have major pollutants. So this is the list of major pollutants. This can be particulate matter, this can be some gases, for example SOx, NOx, carbon dioxide, carbon monoxide, ozone, and we may have different chemicals in the air. So for example, heavy metals we may have volatile organic matter. So the first thing is we must have the sampling. uh, we do have sensors, right? But if we do not have that particular sensor to to see how much concentration of particulate matter we have in the air, so what we have to do is we have to sample it, right? And we have four method of sampling here, if you can see. The first is grab and integrated sampling. Then we can absorb it in liquid, we can adsorb on the solid, and we can also freeze out. So these are different methods of the sampling of the just see, this is for the gaseous air pollutant. But if what we are talking about, if we want to collect the particulate matter, if we want to see the nature of particulate matter that we have in the environment, then again we do have different method. For example, sedimentation, high volume filtration, tap sampler, impingement, electrostatic precipitation, thermal precipitation. So we will talk about this in brief using MCQs, right? Then we have the stack sampling. For example, the gas is coming from the chimneys, then how we can do the sampling? So we have sampling system for the gas, for the particulate matter, and we do have different methods. So the first part is about the ambient air sampling. Ambient means whatever air we have in the atmosphere. So how we can do the sampling, how we can collect it so that we can analyze it further. Okay, so I think this is clear. uh, then now I have questions and you have to tell me, right? So the first method of sampling of the ambient air is the grab sampling method, right? And you have to tell me which one is describing best the grab sampling method. And I do have four options here. The first is a large air volume collected continuously for 24 to 48 hours. B is a small representative portion of air collected at a particular time and space within a short duration. C is a sample obtained after separation of pollutant by sorption. And D is a mixture of several samples taken over an extended period. So I encourage you everyone to give me answer, and please don't afraid if even if you are giving me wrong answer. Okay, Venkateshwara gave me answer B. Okay, I also got um, Priscilla. Hi, hello, good evening. And I think it's B. Okay, yes, I also agree with this. The answer is B. So what it is saying that it is a small representative. Just let me know that sampling is nothing but like we do have population, but if we want to see something out of like the nature of the population, what we are doing, we are sampling it. Like out of 1 lakh population, what we are doing is we are just collecting the data from, let's say, 10,000. So this is nothing but the sampling, but this sample should be the representation of this 1 lakh people, right? So this is the small representation portion of air, and that we have to collect at a particular time or place within a short duration. So this is something we will call it as a grab sampling. And can you tell me the advantage that we have of the grab sampling? So, as I told you, we can sample the air by different way. The one is grab sampling, another is freezing out sampling, then another is absorption in liquid, then another is adsorption on solid. So we do have four type. In four ways, we can do the sampling of the air. We can collect that air. So, what is the advantage of grab sampling over different type of methods? Can you write in the chat box in a very simple word? We can collect the air by different method, and one of the method is grab sampling. What is the advantage of grab sampling over different method that we already mentioned, like the absorption in liquid, adsorption on solid, and freezing out sampling? Okay, Venkateshwara told me that original sample we get. Yes, I again agree. So the advantage is that whatever the ambient air we have, that will be as it is at it as it is. So what we are doing is we are having different type of polythenes, not the polythene that we use whenever we go to the market, but we do have different type of polythene and the polymer in which we can store this air. Okay, so this will be very original air that we will have. Otherwise, whenever we are absorbing or adsorbing, we are changing the nature of the air, right? This is the advantage of grab sampling. I may have something about this. Okay, so here what you can see is this is your evacuated cylinder. So one of the uh, like the box, or you can say the cylinder you can use, is the evacuated cylinder in which you can store your ambient air, or you can sample your ambient air. So, and we do have different type of containers in which we can store, and different method of the grab it in itself. So for example, we can use evacuated container. We can use purging, I will show in the next slide. Then displacement of the liquid, inflation of the plastic bag. Even if we do have plastic bag, we can have that air into it, and using the syringe. And uh, and as I told you, the material of that container will be very different. This can be your vacuum tube, this can be your vacuum flask, this can be your stainless steel canister, right? Okay, so just see here, these are the different containers, or you can say box, flasks, in which we can store the ambient air. And so this will be the part of the grab sampling. So you can use vacuum tube, you can use vacuum flask, inflation sampler, gas displacement collector. And likewise, we do have uh, a lot of tube, flask, or container in which we can grab the ambient air, right? Okay, grab sampling is often referred to as whole air sampling because we have four options here. The sample is altered during collection to separate pollutant. The sample is collected without alteration and represent the air exactly as it is. The several grab samples are combined into one composite sample, and the air is sampled continuously at a very low flow rate. So, can you tell me the answer for this? Venkateshwara gave me B answer. Can I expect more answer from more people? Okay, because we already have talked about this, no advantage of grab sampling, and this is, it will be very original. Whatever gas we have in the atmosphere, this will be stored into some container. So that's why this is also known as the whole air sampling. And yes, I agree with the B. So this is, we are doing, we are nothing. We are not altering the sample, right? So this is the collection of the air without alteration, and this will represent the air originally at it is. So that's why B is the right answer. Okay, so After graph sampling, the another type of sampling is integrated sampling, right? And you have to tell me what happened in the integrated sampling. So in ambient air monitoring, a sample is considered an integrated sample when it is collected at specific time and place within a few seconds. It is collected without alteration and analyzed immediately. It is obtained by combining several graph samples or by sampling at a low flow rate over an extended period, 24 to 48 hours, and it is collected only using stainless steel canister or a glass vacuum tube. So what do you think? What should be the right answer for the integrated sample? Okay, again, Venkateshwara gave me C answer. And yes, I also agree with this. So this is nothing. We are having the graph sampling, right? When there is a continuous graph sampling over a period of time, so this will be known as the integrated sampling, right? So this is obtained by combining several graph sampling or by sampling at a low flow rate over an extended period. So C will be the right answer. If you have any problem, you can let me know. If you are thinking like C should not be the answer, A, B, or D may be the answer, you can let me know. Then I will try to explain why these are not among the right options. Okay, as I told you, we do have different type of container, different type of polymer we use for the graph sampling. And for example, if we want to store benzene, if we want to store benzene in ambient air sampling, then what kind of bag material we will use? So we do have four options: PVF, then Saran Tadler, and aluminized. Okay, Priscilla told me, ma'am, I didn't listen to week four lectures, feeling hard to serve. It's all right. You just need to listen, so you can listen only. Uh, Okay, so Venkateshwara gave me C answer, that is Stedler. So as I told you, different uh, uh, for different type of gases to store into some container, that container material should be very specific in nature, so there is no any leakage, so there is no any alteration, right? So for storing the benzene, we are using Tadler material, using to collect the benzene, and this is the bag material, right? And let me show you a different type of material we can use. So for example, if we want to collect chloride, so VIC, so we should have aluminized bag type, then only we can collect the air into that. If it is hydrocarbon, then this is PVX. If it is again vinyl chloride, then we can use Tedler also. Then hydrocarbon, we have multiple options, we can use different bag types. And then benzene, this was in question, then we will use Tedler type of plastic bag. Then you just see like different bag type we need to store different type of gas or metals, right, from the air. And along with that, we do have different, anyway. So okay, so we have understood that one way to sample the air is the grab sampling or integrated sampling, right? The another way is physical absorption. Okay, the second way is physical absorption, and this question is about that only. So you have to tell me the correct statement about the physical absorption in liquid gas liquid sampling. And we have four options here. It involves an irreversible reaction between pollutant and absorbent. It generally show high efficiency regardless of solubility. It relies on the physical dissolving of the pollutant in the liquid with efficiency depending on solubility and gas to liquid ratio. And it is unsuitable for analyzing pollutant concentration. So, what is the right statement about the physical absorption? What happened to the Venkateshwara? He is giving me a right answer back to back. But anyway, yes, C is the right answer. That physical absorption means, for example, if we do have charcoal, right? If we do have charcoal, what we can do is we can also absorb our gas into that charcoal. So this is the physical adsorption. And you just have to see there is a difference between physical and chemical. If we are talking about the adsorption, so it means it is just getting attached to that, there is a no any kind of reaction. The another is absorption, right? In absorption also we have physical absorption and chemical absorption. In physical absorption there will be dissolving only, and again there is a no any kind of reaction that is happening. But if we are talking about the chemical, then yes, the liquid, so this is nothing like this. This is something, we do have some liquid and we are storing our air in that liquid. Just taking the example of ocean. In the ocean we have water, and we have a lot of carbon dioxide and oxygen in the oceanic water. So this is nothing but the physical dissolving of the pollutant, or you can say any gas in the liquid. So this will be the part of, so this is the one of the method how we can store our pollutant, air pollutant, into liquid. So this is the part of physical absorption, right? So that's why C answer is the right one. Okay, then so we have discussed two methods till now. The first is grab sampling. The second is physical absorption. Then third method by which we can do the air sampling is chemical absorption. And you have to tell me which factor is not a primary consideration when selecting an absorbent: solubility of the pollutant, reactive property of the pollutant and absorbent, subsequent analytical method to be used, cost of the sampling equipment. So what do you think? What is the right answer for this? So for example, if we do have SO2 in the air, and so what we can do is, in the, we have some liquid and that liquid have H2O2. This is hydrogen peroxide. So this SO2 can react with H2O2 and that can give you H2SO4, right? And this is how we can store SO2. And then whenever we will do the titration, we can tell the concentration of SO2 we had in the air. So this will come under the chemical absorption method, by which we can collect our air or pollutant in liquid. Okay, so you have to tell me which factor is not the primary consideration whenever we are selecting the absorbent. So here absorbent is H2O2, hydrogen peroxide. So can you tell me like what can be the answer for this? Anyone? Venkateshwara told me solubility of the pollutant. Not exactly, because solubility will also allow the reaction between these two. So this will the factor. to select the absorbent? And the answer is not a primary consideration. Yes. So Priscilla gave me answer D. So yes, like in laboratory or in developing countries where we do have a deficit of budget, we do consider the cost of the sampling equipment, but this is not the primary consideration, right? Because we have to see the physical characteristic of the absorbent and even the gas that we want to sample, and the compatibility of these two to give the reaction, right? So based on that, the solubility we have to take into consideration, then reaction, and then analytical method. So these are the three that we have to take into account, and the cost we have to ignore if we want to have the accurate or accurate result, and even the higher efficiency to absorb our pollutant into some absorbent, right? So these should be the right answer. Venkateshwara, you raised your hand. Why? You want to ask something or what? Anyway, so I think this is clear that YD is the right answer. Okay, so I'm moving to the next question. Okay, which of the following represent a typical process of physical absorption in air sampling? And we have four options here. Dissolution of CO2 in water without chemical change, reaction of SO2 with aqueous hydrogen peroxide to form sulfuric acid followed by titration. Then C is adsorption of NO2 on activated carbon, and D is absorption of ozone in a plastic bag. And you have to tell me the typical example of chemical absorption of air into some liquid. And we have four options here. Okay, Priscilla gave me answer B, Venkateshwar A. Okay, I'm here agreeing with B. So this is okay. Why A is not the answer? Because there is a no any chemical change. So this is the part of physical absorption. So for example, if we have again we have water and CO2 is getting absorbed into it, and we do not have any chemical reaction there, so this will be the part of physical absorption but not the chemical. So chemical is we are changing it whenever there is a reaction between absorbent and the air, there must be some reaction. So for example, SO2 will react with the hydrogen peroxide and will give you the sulfuric acid, and this sulfuric acid can be titrated with barium chloride, and then this can give you this can tell you the concentration of SO2, right? So this will come under chemical absorption. And if it is the activated carbon or charcoal, then this will again come under physical absorption, because there again there is a no any kind of chemical reaction. And this one is grab sampling, something absorption of ozone in a plastic bag. So this is the part of grab sampling. So as it is, as air we had in the air, in the atmosphere, we are just storing it. So we covered grab sampling, physical adsorption, chemical absorption, right? Till now. Okay. So the second is, which of the following is not a factor affecting the collection efficiency of gas absorption methods? And we have four options here: flow rate, bubble size, liquid column height, chemical nature and concentration of pollutant and absorbent. Temperature, pressure, and pollutant solubility. Brand of the glassware used in the sampling setup. I think very simple question. There is a one odd one out. You can tell me very fast about that. Okay, so Venkateshwara gave me D answer. So yes, I agree with this. The brand of the glassware. So the brand is nothing but like the one which is maintaining the flow rate, which is maintaining the bubble size, which is maintaining the temperature, pressure. Uh, so this brand is, and some brand not may not have that uh, characteristic feature. So we are keeping this aside, but just we have to say is okay, so whenever we do have flow rate, high flow rate, so the efficiency will be reduced. Whenever we do have a very slow rate, the efficiency, because here what we do have, let's say, water, and then some air is getting absorbed into that air. Whenever we will do have the flow rate higher, then efficiency will not be higher, but uh, the flow rate is slower. When the oxygen is coming slower to the ocean, then the efficiency will increase. Bubble size, whenever we will have more bubble, or the large so sorry we whenever we will have more bubble, or the bubble size is short, then the efficiency will increase. Then liquid column height, again, whenever we will have more height, then more collection efficiency we will have. So this is not the right answer, right? Because here we do have not. Then the chemical nature and characteristic concentration of pollutant and absorbent. As I told you, the absorbent must be compatible with the air or with the pollutant, with which there should be some compatible reaction. So that's why this is again the right one. So this is not so this will not be your answer. Then temperature, pressure, pollutant solubility. As you know, there is a one rule. Can you tell me where partial pressure is directly proportional to the concentration? Something Henry law, right? So this is also affecting the collection efficiency. This is not affecting your collection efficiency. Okay, not directly. So D is the right answer. Okay, the simplest and most commonly used device for gas liquid absorption in atmospheric sampling is what? And we have four options here: fritted glass absorber, impinger, ordinary glass washing bottle with gas washing bottle with absorbent and gas dispersant tube, and we have vacuum flask. What do you think? What is the right answer? Most of the time, whenever we want to do the sampling of the gas and we want to store into the liquid, so what kind of device we most of the time use? Okay, I'm getting like a diversity in the answer right now. Few people is giving me D and B and A, but the answer is C. So because it is commonly used device, then most of the time we do not have very specifically designed device. So we people use very ordinary or very simple gas washing bottle that have the absorbent and gas dispersant. So this is something like this. We do have bottle, and that bottle have a tube, and in that, and the gas will come under this tube, and here we may have some cork that can or valve, you can say, that can manage the in and out of the air. So most of the time we do use this one. But what and if it is the fritted glass absorber is nothing, but whenever you have a glass vessel, but along with that we do have a tube. That tube have very porous filtration kind of disc. So what it will do, whenever air will come into that, because we have porous disc, this one, so this will create bubbles. And this is how, if we will have more bubbles, then more of the air will be dissolved into that liquid. Okay, so if it is a fritted means we have this porous disc, and that will increase the bubbles, and this bubbles will increase the efficiency of the absorbance, right? If we are talking about the impingers, then impinger means nothing but, again we have some flask, and let's say if we do have such kind of things, it means what we are doing, we have air and we are trying to give more time to the air to be absorbed. The first thing, the second thing is, we are giving this air to strike on these surfaces intentionally. So whenever air will strike on that surface, it means we will have more collection efficiency. So this will come under the impinger. And the another is vacuum flask. So vacuum flask is the not the part of chemical or physical absorption, but this is the part of the grab sampling. If you want to collect the air as it is, irrespective of it being dissolved in liquid, right? So this is not the part of your gas liquid absorption, but this is the part of grab sampling. So most of the time we use the C option, right? So C will be the right answer. And just see here, we do have different kind of absorber. So we can have very simple gas washing bottle, as we already have mentioned. And you have to see here, there is a different capacity of different absorber, and we have to maintain that sample rate as well. So how much ml of that air is coming per minute. We may have spiral or helical, so it means it is increasing the air and it is striking the air to the surface, so that absorbance may increase. Then fritted bubbler, I already have explained. Then bead column. So what, in the column we will have glass beads. Again we are increasing the surface area and the probability to strike on the surface and the collection of air into the liquid. So this different type of absorber we can use. Okay, so the next is most absorption device used in atmospheric sampling apart from gas washing bottle. We already have talked about this, that most of the time we are using this, but what different most absorption device we use in atmospheric sampling? So we have four options: bubbler and syringe, fritted glass absorber and impinger, then vacuum tube and stainless steel canister, syringe and toddler bag. I got answer B. Okay, so just see that this is the part of the grab sampling, right? This is the part of grab sampling. These two are the part of chemical absorption or physical adsorption, you can also say. So if we will see, then yes, B is the right answer. Then along with gas washing bottle, we are also using fritted gas absorber. It means it will create more bubbles of that air into the water or into the liquid, so that absorption can be increased. And impinger means we are increasing the surface area on which it can strike, and based on that the collection again can also be increased. And okay, so I was showing you uh, the impinger with my bat sketch or drawing. Here you can see, if we are talking about the impinger, then this is something, the tube we may have, through which gas can be collected, and this is something that that will give you more strike of gas into your liquid, right? And if we do have that frit means this is something very porous disk, and that porous disk will create some bubbles and again more absorption. So such kind of absorber we do use. And if we do have fritted glass absorber, then it has the most efficiency, and this is uh, whenever pore size is near to 50 micrometer, then this will be more efficient. Okay, so one analyzer, that is Orset gas analyzer, we people use in the laboratory, that will measure the composition of flue gases. Can you tell me what do you mean by flue gases? And which of the following absorbent gas pair is correct? So as I told you, in physical or chemical, mostly in chemical absorbent, we must have some liquid absorbent, and into which the gas will be absorbed. And if we want to measure the composition of the flue gas, then what kind of absorbent we must have? And can you tell me the correct pair of absorbent and gas? Venkateshwara told me that if we are talking about the flue gas, then it is coming from chimney. Yes, and what kind of gas? Uh, like in that gas, the major proportion of which kind of gas we may have? It is mostly SO2. It is mostly SO2. You are correct that whenever we do have like chimney, and out of the chimney we are having the gas releasing, then this will be flue gas, and most of the time this is sulfuric acid, right? So can you tell me the correct absorbent we need for a particular gas? Priscilla gave me answer C. Okay. But the answer is D. We people use potassium hydroxide. Okay, so D is the right answer. So we people use potassium hydroxide liquid to absorb CO2. And let me tell you what different type of absorbent we can use for different type of gases. So this is your Orset gas analyzer, where we do have different type of absorbent. We have potassium hydroxide, we have alkaline pyrogalol, then ammonical cuprous chloride. And if we want to absorb CO2, then we will use this caustic potash. Then if we want to absorb oxygen, then we will use this one. If we want to absorb carbon monoxide, then we will use this one. So these are different type of absorbent we have, in which we can absorb different gases, right, that are coming from the chimneys. And the leftover gas will be assumed as nitrogen. But we may have different absorbent that we may use, so that we can also isolate some other gases we may have out from the chimneys, right? So just keep in mind that these are three absorbent that we use for absorbing three different atmospheric gases, or the gas that are coming from the chimneys. Okay, we were talking about the chemical absorbent, right? We had the liquid absorbent and we were absorbing the gas. But what about the adsorbent? So this is something about, we were talking about the physical adsorbent. by which also we can sample the air. And you have to tell me which material are commonly used as adsorbent. We have activated charcoal, alumina, silica gel, then potassium hydroxide, water methanol, acetone, then sarin, Tadler, Mylar. Okay, so Priscilla and Venkateshwara gave me A. Yes, so I agree with this one. So this one is the right, because this is the part of chemical absorbent, right? This is again the part of chemical absorbent, and this is. Can you tell me what kind of sampling it is? Whenever we are storing into some bags, then this will be your grab sampling. Yes, so this is the part of your graph sampling. This is the only option where we are using some solid. So this is not the liquid. We do have solid surface, and into which we are absorbing the gas, right? So this may be activated charcoal, alumina, and the silica gel. So this will be a part. This will be the part of physical adsorbent. Okay, can you quickly tell me the major limitation of adsorption sampling? Require very high amount of gas sample, irreversible adsorption and variable desorption efficiency, inability to collect gas at low temperature, excessive dependence on chemical reaction rate. Little trickier, but I think you can tell me. What is the major limitation of adsorption sampling? Any guess about this? Okay, so the answer is not D, not D, but this will be B. Because like if it is a chemical reaction rate, then this will be your chemical absorption. This will not be your physical absorption. So this is not the right answer. And uh, if we are having the adsorption, then there is a negligible impact of temperature on that, and it require very high amount of sample gas. No, this is again not the case. But the sometime what problem we may have it, for example, if we have charcoal, right, and if we may have silica, and if there is a adsorption on that charcoal or silica, but to get that charcoal or silica in the original form, or to extract our air from that charcoal or silica, that is little more difficult for us to extract gas from the adsorption site, right? So that's why, and even the efficiency of this adsorption is very low. So this is the major limitation. So that's why B is the right answer. Okay, how can gases collecting on adsorbent like charcoal be recovered for analysis? So how we can recover? So for example, there is a some connection, physical connection between charcoal and air. Then how we can collect our air from that charcoal? What kind of method? What kind of analysis we can have by which we can recover our pollutant or air from that charcoal? So we have four options here. Only by dissolving in strong acid, by applying heat using inert carrier gas or chemical treatment, by cooling the adsorbent to sub-zero temperature, they cannot be recovered once adsorbed. What do you think? How we can extract? Uh, Venkatesha. So just think about that. If we are using adsorbent, and these adsorbent are used to are used for the air sampling, it means we have method by which we can extract the air out of that absorbent. So I don't think that D will be the right answer, because this is the one of the method of air sampling, right? So we have to extract our air from that adsorbent. Pradeep gave me B and Priscilla also gave me B. Yes, I also agree with B answer that if we are applying some heat, or if we, so this is something like this. So this is, let's say, charcoal, and on that charcoal we have some air absorbed into it. That if we are having some carrier gases that are inert in nature, then because there is a very weak link between this adsorbent and the gas, so whenever we will have this inert carrier gas that can remove pollutant from that charcoal, right? And we, even after applying the heat, this can be, the bond can be broken down. So that's why B is the right answer. Okay, so till now, what we have learned is that we can collect the air using grab sampling, using liquids, using some solid. Okay, the fourth method is how we can store our air or pollutant in the air is using the cold trap or the freeze out sampling, right? So there is a one method that is freeze out. So, and different liquid we can use, of which by which we can maintain some temperature in negative, and because we will have very low temperature, so this is how we can freeze out our air, and this is the one method by which we can store our air, right? And if we want to maintain the temperature minus 79 degrees Celsius to store the air, so what kind of cold trap we will use? So we have four option here: ice and salt, dry ice and acetone, liquid nitrogen, liquid oxygen. Okay, so I'm having C answer, B answer, and the answer will be B here. So to maintain the temperature of minus 79 degrees Celsius, we will use dry ice and acetone, and different chemical will maintain different temperature, right? So I do have a list to show you. And just see here, what we have to do is, when the air is coming out, coming in into that container in which we have such kind of chemical that can maintain a very low temperature. So firstly we will have ice salt, then this will air will come, will go and pass through the dry ice and acetone, then there will be liquid nitrogen, and this is how this is the sequential steps. And if, let me show you different temperature. So just see here, if we do have ice water, then the temperature we can attain is 0 degree. If we have ice salt, then this will be minus 21 degrees Celsius. This was in question. And the minimum temperature that we can maintain is using liquid nitrogen, and this will be minus 196 degrees Celsius, right? So this is again one method by which we can store or we can sample our pollutant, right? Okay, so we started from here. So we talked about different gases, and for that we need to collect different gases. We talked about this grab sampling, we talked about absorption, we talked about adsorption, and we talked about the freeze out sampling. Okay, so our next target is to see different sampling method used for particulate matter, and these methods will be sedimentation, high volume filtration, tap sampler, impingement, electrostatic precipitation, and thermal precipitation. So this we will not talk much about air sampling, and this is how we will complete our first part, that is how we can sample or collect air, right? And in that air, particulate matter is the one of the major pollutant we have. So we are moving to the particulate matter now. Okay, so the one method is by the sedimentation, and this is suitable for what kind of particulate matter? Can you tell me the size of that particulate matter, uh, which we can efficiently collect using sedimentation method? So we have four options: particle less than 2 micrometer, particle more than 10 micrometer, only gaseous pollutant, aerosols smaller than 1 micrometer. So I got answer from Venkateshwara. B answer: particles more than 10 micrometer. Is it? Okay. So yes. So sedimentation is nothing but we have some jar, and that jar. Okay, I have figure. Why should I draw? Um, so something like this. Uh, Here you have the container. Here we do have uh, a porous or filtered, uh, uh, so that whenever we will have the air, then based on this pore size, the air, some of the particulate matter will come down to that bottle or to that container. So this is something very simple: sedimentation, or you can say the dust jar. So, and this we can use for the particulate matter that have the size more than 10 micrometer, because here we are not using any kind of technology, we are not sucking that air, we are not using any kind of gradient, but this is simply that we do have a jar, and that jar have one container that have the porous base, right? So this is sedimentation jar. Let me clear this. Okay, the next method by which we can collect the particulate matter is high volume filtration, and this is primarily used for collecting only gaseous pollutant, measuring particle larger than 20 micrometer, collecting suspended particulate matter in the range of zero point 0.1 to 20 micrometer, and measuring only dissolved solid in air moisture. Okay, so I'm getting C answer from Priscilla and Pradeep. So yes, so if we are talking about the high volume filtration, then here we are using some motors. That motor will suck the air, and the volume will be known. And based on that, if there is kind of pressure that is taking the air in, it means a lot of particulate matter, the size of which is very small, that can also be sucked in into that container. So this is how we can maintain the range of zero point 0.1 to 20 micrometer. So C is the right answer, and let me show you like how it looks. So this is something like this: air will come out, air will come in, and this is the filter. And because here we do have some motor, so that motor will suck that air and will give you the air out. But because here we do have the filter paper, or like filter technique, so in which on which the particulate matter will be deposited. So this will show you 99% efficiency for particle that have the size zero point 0.3 micrometer and can effectively trap particle as small as zero point 0.5 micrometer, right? So this is the one method how we can collect particulate matter. Okay. um, Again, we are talking about the high volume sampler. So here air is usually drawn through the filter for 24 hours. Approximately how much air volume passed through the filter in this period? And we have four options here: 20 meter cube, 200, 20,000, 2000, and 20,000. Let me see the answers. Venkateshwar gave me D answer, and but the answer is B. So most of the time in 24 hours, as I told you, how much air will be taken up by this high volume sampler, this volume will be known to us. So most of the time in 24 hours, we maintain the flow rate in such a way that in within 24 hours, 2000 meter cube of the air can be come in and then can go out, and in the filter the particulate matter will be deposited. Okay, so coming to the next question. Okay, the next method by which we can collect the particulate matter is tape sampler. And you have to tell me the main advantage of using tape sampler in ambient air sampling. And again, we do have four option here. It can collect only gaseous pollutant continuously. It allow automatic advancement of tape to collect discrete particulate sample at set interval. It eliminates the need for pumps in sampling. It can only be used for liquid pollutant sampling. Okay, I already have some answers. Priscilla and Pradeep gave me B answer. Yes, I also agree with the B. So the main advantage is it is automatic. Okay, and here, but whenever we are setting the time, okay, so after 1 hour we need particulate matter concentration. After another 2 hours we need the particulate. So we just need to set, and this will give you the automatic concentration of the particulate matter. So this is the advantage of tape sampler, and let me show you the figure of this. Something like this. We do have tapes, and we have to control it digitally, and based on that we can collect particulate matter on that tape. Okay, then another methods that we haven't discussed right now to collect the particulate matter is wet impingement, dry impingement, electrostatic precipitation, and thermal precipitation, by which we can collect the particulate matter. But which method is achieving nearly 100% efficiency for the particle that have very small size from 10 to 0.01 micrometer? And under a strong temperature gradient. So can you tell me the answer? Pradeep gave me D answer that it is a thermal precipitation. Yes, I also agree with this because this is under temperature gradient. So whenever we will have the hot uh, uh, or high temperature and low temperature, then and if we are creating that gradient, then the particulate matter will move from high temperature to low temperature because we have created the gradient, and this is how we can achieve 100% efficiency. uh, Pradeep told me that temperature gradient is for thermal. Yes, exactly. From that word, you can catch which answer will be the right one. If we are talking about the wet impingement or dry impingement, it is nothing but again we have liquid or we have solid into which we are absorbing this particulate matter. Okay, so this will be the wet impingement or dry impingement. Electrostatic precipitation, you have heard about this, something like this one. So what we do is we maintain positive and negative charge into that electrostatic precipitator, and whenever the air will come, it will be positive charge or negative charge. You can read about this, but the thing is there will be different charges. I think this will give you the negative charge, and then because we will have the positive charge in the surface or at the base, so this is how this will be attracted, and the particulate matter will be deposited at the bottom and air will go out. So just think that we do have different charge gradient we have in the electrostatic precipitator by which we can collect the particulate matter. And the thermal we already have talked about, right? So D is the right answer. Okay, here you can see, as I already have talked about these things, I think we can skip the reading part. Okay, so we have done this much, and right now I do not have question on this stack sampling. Stack sampling means whenever we do have chimneys, and so to collect the air from that chimneys, then this will be the part of the stack sampling. And this is the ambient, so in the atmosphere what kind of pollutant we have, and if we want to collect that, we need such kind of sampling. And for the chimneys gases, we need this type of sampling. We are not covering right now this, but we are uh, moving to the water sampling and the analysis part. Okay, this one is after sampling. You already have collected the air, right? You have collected the particulate matter. You have collected different kind of gaseous pollutant in liquid, in solid, and even you have done the grab sampling. And now you need to analyze the concentration of each of these pollutant. Okay, so we do have different instrument and techniques by which we can get to know the concentration of different gaseous pollutant or particulate matter. So these are different techniques, you can read about this. And we are moving to the next one. Okay, so sampling is done, but now the main task is to measure, right? And for an NOx measurement, we do use chemiluminance analyzer. And but here, how you will determine the total NOx? Okay, Pradeep asked me question. Can we say that stack sampling is only for point source of emission? Yes, you are exactly right, because this will be the part of point source. And here, what we do is just so for example, this is your uh, chimney, and what we can do is here we can use some filter, or here we can use some sensor. So this is how this is just like ambient, but because it is coming from the chimney, so the name is given as the stack sampling, but it is very much similar to the ambient air sampling only. And yes, this is the part of point source of emission. Okay, so right now we are talking about the analyzing part. We have collected our gaseous or particulate pollutant. So right now, can you tell me if we are if we need to know the concentration of NOx, then in a chemiluminance analyzer, how we will determine the total NOx? Just from this terminology, I think you will able to give me the answer. Chemical related luminance, brightness or lighting or excitement of electrons. So from that, I think you can give me the answer. Okay, so I'm getting the answer B and B. Yes. So yes, this is B. So what will happen? We what we are using is using some ultraviolet radiations. We are breaking this NO2 to NO. Okay, and then we will react this with the ozone. So what will happen? This will create some oxygen, and nascent oxygen, and that will emit some light, and that emitted light we can use to measure NO2 amount. in chemiluminescence analyzer. So that's why B is the right answer. Okay, so here you can see we have NO2. Photolytic means using sunlight, ultraviolet radiation we will use to break down this NO2 to NO, and then we will have the reaction with the ozone, and then whatever light it will emit, that light will be sensed by your will be multiplied by photo multiplier tube and will sensed by some sensors. So this is how we can analyze it. Okay, so the air part is completed, and we are now moving to the water sampling and analysis. And water sampling is very easy because we need to just collect the water. So this is not necessary for us to have, because the collection of air is very difficult for us, because it can disperse out, right? It can diffuse out. But if it is a water, then we just need to do is we need to collect the water at different length and different depth and at different places. Okay, so we do not need to much worry about the water sampling, but different characteristics we may need to measure of water. For example, BOD, COD, or different metals we may have in the water. So the analysis part is more important in water sampling rather than water analysis is more important rather than analysis, because sampling part is very easier for us. Okay, so the one way to sample the water is the composite sampling, right? So what do you mean by this composite sampling? So here the question is, a composite sample in wastewater monitoring is best described as what? So a simple large volume of water collected at one time, a sample collected only during extreme flow condition, a mixture of individual sample collected at interval, either manually or automatically, a sample that must be stored for at least 24 hours before analysis. So everyone gave me answer C. Yes, so just like from the name only, composite means mixture of different samples. So for example, we have different sample at different length. So for example, at 1 centimeter, at 2 centimeter, or let's say at 1 meter, we do have uh, different water sample at different height, and then we will mix it. Or what we can do is, in the 10-day interval we have 10 sample, but we will mix it so that we can have some average or representation of that water. So because it may be that on one day some industries has released a lot of pollutant in the water, so this will not give you the representative, right? Representative will be when every day, or let's say for 10 days continuously, at that particular time or at different time, you are collecting the sample and then you are mixing it. So the composite sample will be whenever you mixing the individual sample that has been collected at different interval, and it can be manually or automatically. So this will come under the composite sampling. uh, in water sampling we just have two type of sampling. The one is grab and the another is composite. So grab is just like that, we are just collecting the water out of river, out of any wastewater flow, right? And the composite it whenever we are mixing that particular different samples, and that will be composite sample. Okay, which of the following parameter preservation combination is correctly matched? So for example, we have water sample, right? But if you want to see the BOD or let's say COD, either you have to measure it uh, in within 1 hour or within half an hour, because otherwise there will be some reaction or your BOD and COD will be changed. So what you have to do is you have to preserve your water, wastewater, out of which and after some days or after few hours you can do your analysis part to know the concentration of BOD or COD. So you have to tell me the correct matching combination. So Pradeep gave me answer C. Mithur gave me answer C. Okay. Yes. So if we want to, okay. So water may have different parameters. Okay. We may check the hardness of the water. We may check the total dissolved solid in the water. We can also check different metal in the water. So if we want to analyze the cyanide in the water, then the one way to preserve that water sample is that we have to raise the temperature, pH of the water more than 10 with NaOH, and that's how we can hold that water for 24 hours before analyzing it, right? But within 24 hours we have to do the analysis for the cyanide analysis, right? So let me show you different okay, so I just wanted to show you here, like these are the different parameters. Some are solid parameter, these are the physical parameter, these are the chemical parameter. Some anions and cation concentration we may measure in the water, and metal, total organic dissolve. So here we will see how we can how different technique or analysis by which we can do the analysis of such kind of parameters, right? So what I was showing you is this one. So, for example, if you want to calculate the BOD, then the maximum holding time is just 6 hours. So, it means whenever you are collecting the wastewater out of some river or from some stream, then within 6 hours you have to do the analysis for BOD, and you can do the preservation whenever you are refrigerating it at 4 degrees Celsius. If it is COD, if you need to analyze the COD, or if you know the concentration of COD, then the preservation method will be 2 ml H2SO4 per liter, and this is how you can hold uh, your sample for 7 days. So likewise we do have different parameters. For each of that parameter we do have different preservation method and different maximum holding time. So you have to see if you have water sample, then what kind of parameter you want to measure, then for that particular parameter what kind of preservation you can use, and what maximum time that preservation will allow you to keep it as it is, and after that you can do some test on that, right? So I think we may have more. So, like for nitrogen that we have in water, for phenol, for phosphorus, sulfide, odor, turbidity, and coliform bacteria. So, likewise, we do have different parameters that we can measure, and preservation method is different for different kind of parameters. Okay, so which of the following parameter measurement method pairs is correctly matched? So you have to tell me what kind of technique or method we do use for the analysis part of that particular parameter, and you have to select the correct match. So here we have TDS with turbidity meter, alkalinity with pH meter, trace metal with gravimetric method, color with threshold order number. Venkateshwara gave me C. Gravimetric method is used for no. not for the trace metals. I will show you. Mithur gave me B answer. Obviously, if you want to see the alkalinity or acidity of the water, you will use the pH meter, right? So this one is the right, and why your A, C, D is not the right answer? Let me show you. Okay, so if you want to measure total suspended solid, then you will use the turbidity meter. If it is the color, then you will use the spectrophotometer. If it is the odor, then this will be the threshold odor meter. For TDS, total dissolved solid, this is the gravimetric or conductivity meter. Okay, that's why that C answer is not the right one. And for alkalinity, we will use the pH meter. For inorganic substances, we will use some chemical methods. We will talk about some of the chemical methods, and spectrometer we may use. If we do have the trace metals, and if we want to know the concentration of trace metal in the water, then we will use AAS or ICP MS. So these are the different methods that we can use for different parameters. Okay, because we are talking about parameters and different method that we can use for the determination. So for example, if you want to determine the dissolved oxygen into your water, then we do use one method that is known as the Winkler method. And here the role of dissolved oxygen is 2. So we do use different different chemical with which the dissolved oxygen will react, and then there will be some precipitation, or there will be some complex compound that will be formed, and using titration we can determine the dissolved oxygen. Okay, so here the one step is that dissolved oxygen will make reaction with something, and then will happen something, and then using titration we may get the concentration of dissolved oxygen, right? So the role of dissolved oxygen is to what here? Okay, I'm getting Method is giving me C, and then Priscilla B. Mm, okay, so I'm going with the C answer. That first step will be there will be the reaction of dissolved oxygen with the manganese, and that will give you the brown precipitation. Okay, let me show you the different step we have to measure the dissolved oxygen. So just see here. So what we have is, first we have oxygen that is dissolved in the water, right? And we will add magnesium sulfate into our water sample. So this is the magnesium, and that will give you the MnO2. Okay, and then what will happen whenever there is a reaction of this MnO2 with your iodide ion, then this will give you I2. Okay, and this is said that the number of the moles of I2 will be equal to O2. Okay, so if we want to see the concentration of oxygen, then we have to know the concentration of I2. And how we can know the concentration of I2? This we can use using the titration. So we have to do with the sodium thiosulfate. If we are doing the titration of I2 with sodium thiosulfate, then this will be 2I minus, and this is how we can know the concentration of I2, and hence the oxygen concentration. So this is the one of the chemical method by which uh, uh, we can estimate the concentration of dissolved oxygen into the water. Okay, because we already have discussed the methodology here. So in Winkler method, liberated iodine is quantified by titration with what? We already have discussed potassium dichromate, sodium thiosulfate using starch indicator, ADTA using aerochrome, black tea, potassium permanganate. Okay, now I'm having answer. Methur gave me B, then B, B. Okay, so everyone is giving me B. So yes, this is sodium thiosulfate that we will use for the titration purpose. But see, each method, whatever we have for different parameter, uh, that may have some limitations, or it may be like some of your chemical can react with different other parameters that we may have in the water. Okay, and for that we have to remove that. So it may be like along with dissolved oxygen you may have nitrate, you may have ferrous ion, or you may have suspended solid into your water, right? And that kind of parameter can give the disturbance or interference with the Winkler method. So you have to add something, some chemical into your flask so that the disturbance or interference can be avoided. So you have to tell me what kind of firstly what kind of interference we may have whenever we are determining the dissolved oxygen, and then how we can remove it. Okay, so Venkateshwara and Mithur gave me D answer. So yes, so we may have nitrite, we may have ferrous iron, we may have suspended solid in the water along with the dissolved oxygen. Then we have to add permanganate so that we can remove the interference of nitrite. We have to add azide so that we can remove the interference of ferrous iron, and then alum to remove the interference of suspended solid. Okay, so that's why D is the right answer. Okay, so one method is Winkler method to determine the concentration of dissolved oxygen. The another method is membrane electrode method to determine the dissolved oxygen. And here the current generated is proportional to what? pH of the sample, total dissolved solid in water, partial pressure of oxygen across the membrane, and the concentration of silver ion in the electrolytes. Venkateshwara gave me C answer. From yes, so this is something like we do have a membrane, right? And whenever we will have more pressure on that membrane of the dissolved oxygen, that will be the proportional to the current generation, and that current will give you the amount of concentration of dissolved oxygen we may have in the water. So C answer is the right one. I don't know I have figure or not for this. Okay, I do not have figure for this. Okay, the next is in standard BOD measurement, the sample is incubated in complete darkness for 5 days at temperature what? What kind of temperature we should have to measure, to do the BOD measurement? Mithur and Venkateshwara gave me, okay, Mithur gave me C answer. Pradeep also gave me C. Priscilla with C with question mark, and Venkatesha C. So yes, so C is the right answer. So just see that if we want to calculate dissolved oxygen, then dissolved oxygen is just after your sample, whatever sample we have, within few hours we have to analyze it using Winkler method. But BOD is what? We have some organic matter into your water, then uh, this oxygen will be depleted over the time. Okay, so what we have to do is we have to measure dissolved oxygen in zero time, and then we have to measure the dissolved oxygen after 5 days. Okay, then after some time the dissolved oxygen will be less. Okay, so if we are subtracting it, then we will get the BOD. But for that, we have to wait for 5 days. We have to wait for 5 days, and the temperature should be 20 degrees Celsius. Then only we can determine the BOD 5. So C is the right answer. So we use calcium chloride, magnesium sulfate, and ferrous chloride and phosphate buffer to the dilution water in a BOD test. But what is the purpose of that? So we have four options: to prevent bacterial growth, to provide essential nutrients for microbial activities, to neutralize acidic wastewater, to remove dissolved oxygen. Pradeep and Priscilla gave me, even Venkateshwara gave me B answer. The answer is B, but somehow I gave the answer A, but I think this is by mistake. But answer will be B only. Okay, the next is, if unseeded wastewater is tested, then BOD5 is calculated as how? So this is the difference between DO of sample at 0 and 5 days only. Difference between sample and blank DO consumption values, only the DO value of the blank after 5 days, ratio of initial DO and final DO in the sample. So I got A, C maybe. Okay, so the answer is B. So first you have to understand what is unseeded wastewater. So unseeded wastewater is, so for example, you are having 5 ml of wastewater. Okay, but you have to dilute this water. Okay, so for example, we are adding 295 ml of water to make it 300 ml of wastewater. Okay, so this is the dilution water that we are adding into 5 ml, and it will be and why we are doing the dilution? Because sometime the BOD value is so higher that it will be very difficult for us to measure it using 5 ml. So we have to do is we have to do the dilution. Okay, so this is something dilution we do, and here we are assuming that the BOD, so we do not have the BOD, and BOD is very constant for this dilution water, or we can assume that uh, the BOD of this dilution water is 0. Okay, the one condition is that. The second condition is, so this will be unseeded dilution. So this is unseeded dilution. But sometime what is happening is that it may be that the BOD, it is very difficult for us to calculate the BOD because the activity is very low. Then this dilution, whatever we are having with this 290 5 ml, so this may also have some microbes, so we will add some microbes into that, and so that's why it will also have some BOD. So this will be the seeded wastewater. So whenever we are diluting our wastewater with the water, uh, then it may be that that water itself have some BOD. If that water itself has some BOD, then this will be the seeded, and if it doesn't have the BOD of itself, then this will be the unseeded. So here we are talking about the unseeded wastewater. So here it is just the difference between sample and the blank DO consumption values, right? So just see here. So if it is unseeded sample, so in that unseeded, what we are doing, so this is our sample and this is our blank, and for the sample we are calculating the DO at 0 time, and after 5 days we will have the blank. Then we also calculating the blank DO at 0 time and 5 after 5 days, and if we are subtracting it, then we will get the BOD after 5 days, right? But if we do have the seeded sample means we are we have first we are doing the dilution, the first thing. The second thing is, in dilution we may have BOD of that diluted dilution water itself. Then the two term is here, the D is the dilution factor, and F is the ratio of seed volume in dilution solution to seed volume in BOD test, uh, BOD test on seed. Okay, so this is how the formula will be changed. And I think I have one question on this so that you can understand. Okay, so the question is, if industrial wastewater is diluted 1,000 time, sorry, 100 time for BOD 5 test, initial DO for both sample and blank is given 10 mg per liter. uh, then after 5 days at 20 degrees Celsius, DO of the sample is 3 mg per liter, DO of the blank is 9.7. And first you have to calculate what is the BOD of the original wastewater, and then how does it change if 5 ml of seed is used in 300 ml dilution water. So a very basic formula that we already have discussed will be used here. Let me show you. So the first case is, we need to calculate the BOD when there is no any seed. Seed means we are not putting any dilution water into that, and in that dilution water we do not have any BOD. So this is unseeded. So but here we, because we do have the dilution, but we do not have any BOD of that. So the formula will be D, that is the dilution factor, and simply what we already have seen, and this is how we will get the answer for first part. Then if we are going to the second part, we have to calculate F. We have to calculate F, and this F is seed volume in diluted sample upon seed volume in seed control, and this will be here 4 point the last step you can see here, 4.95 upon 5 is equal to 0.99. So this will be your F. I don't think that in a very short time period I'm able to make you understand, but just try to understand. And then for the seeded, we do have that formula. Simply we will put the values, and this is how we will get uh, the seeded BOD 5 calculations. Okay. The next question is very reasonable. Why is the BOD bottle kept in total darkness during incubation? To avoid oxygen loss due to heating, to prevent photosynthetic oxygen produced by algae, to stop microbial respiration, to maintain constant pH. So Venkateshwara gave me a B answer, to prevent photosynthesis, oxygen production by algae. Yes, so this is the right answer. Like for 5 days, we have to keep this BOD bottle into darkness, so that there is no any oxygen added into that bottle, and this is how we can prevent the wrong determination. So B answer is the right one. Okay. After COD, after BOD and dissolve oxygen. So we have learned how we can measure BOD, how we can measure dissolve oxygen, right? The another is COD. This is uh, chemical. What is the full form of this COD? Can anybody tell me? Okay, everyone is giving me an answer, I think, without giving me. Can you tell me the full form of COD? Chemical oxygen demand. Yes. So COD is chemical oxygen demand. Here we are not using word BOD, biological, right? So it means whatever organic matter we have, we can just oxidize that a particular organic matter using some chemicals, but not using the microbes, right? So in COD measurement we are using potassium dichromate and sulfuric acid, and these are used for what? Out of A, B, C, D, why we are using potassium dichromate and sulfuric acid? Okay, so Pradeep and Venkateshwara give me A answer. So yes, A answer is the right one. And why this is, as I told you, in BOD, we do rely on the biological degradation of organic matter, but in COD, we are relying on some chemical that are the oxidizing agents. Yes, and that oxidizing agent will oxidize the organic matter into CO2 and water, right? So potassium dichromate is the oxidizing agent. And so that's how in COD, organic matter will be oxidized. Here you can see the first part is CHON is your organic matter. Then we do have dichromate, chromium, and then this will give you CO2, H2O, and ammonia, and some different uh, uh, chemicals it may produce, but most of the time it is CO2 and water, right? Okay, the endpoint of COD titration using FAS is indicated by what? So there must be change, right? Whenever we are doing the titration, there will be some endpoint or the turning point where the color will be changed. So if we are doing the COD titration using FAS, then what kind of color will be changed? So change from reddish brown to blue green, change from blue green to reddish brown, appearance of a yellow color, disappearance of brown precipitate. I think this is purely chemistry based, but okay. So this will be changed from blue green to reddish brown, and B is the right answer. Okay, again, there may be some interference by some of the pollutant we may have in the water or in the wastewater. Then, which of the following substance interfere in COD measurement? Sulfate and phosphate, chloride and nitrite, calcium and magnesium, carbonate and bicarbonate. Pradeep gave me B answer, chloride and nitrites. Yes, so two substances, chloride and nitrite, that will give you the interference in COD measurement. So just here you can see they, because this chloride and nitrite can be oxidized by dichromate and can create an inorganic COD. So this will give you the higher value of CO2, COD, because oxidizing agent such like dichromate can oxidize chloride and nitrite as well, right? So this can be eliminated by using sulfamic acid to remove the interference of nitrite. And if it is the chloride, then we can use mercuric sulfate prior to the addition of other oxidizing agents, so that we can remove the interference of chloride. Okay, so you have learned how we can calculate BOD, how we can calculate a COD, right? And if we have the wastewater sample that have the ratio of BOD to COD is greater than zero point 0.8, so this will indicate what? The wastewater is highly toxic, wastewater is chemically stable, wastewater is highly biodegradable and amenable to biological treatment, and wastewater require only physical treatment. So Mithur gave me answer C. Uh, yes. So whenever we have BOD COD ratio greater than zero point 0.8, it means that we have like we have 80% of our COD is BOD. Okay, so it means we have we have uh, organic matter that can be degraded by biologically using the microorganisms. So that's how this is wastewater is highly biodegradable. Okay, so another method by which we can measure COD is by colorimetric method, and here we are using spectrophotometer, right? And we have to see the absorbance of chromium, and that we have to measure at particular wavelength. So, can you tell me at that wavelength that we have to uh, that will be absorbed by chromium, and that's how uh, the intensity of the light will be reduced, and this will give you the concentration of your COD. Okay, Pradeep gave me B answer, and yes, so this is B. So whenever we are giving the light of wavelength of 350 to 654 nanometer, that light of that particular wavelength will be absorbed by the chromium, and that's how uh, the light will be absorbed, right? And then using your Beer Lambert law, you can calculate the concentration of your COD. This is the method. I think I need to skip here right now. Okay, the another is TOC. What is TOC? Total organic carbon. If you want to measure TOC in the water, then which instrument is commonly used to detect carbon dioxide in COT measurement? And you have four options here: AAS, gas chromatograph, NDIR, and UV visible spectrophotometer. Mithur gave me C answer. That is NDIR. Yes. So C answer is the right one. And just see here. So we have in the air, we do have CO2, right? And then what we will do is, so because in the organic carbon test we have to do the oxidation of organic matter, and that oxidation will give you the CO2, and that CO2 we can measure using one instrument. That instrument is NDIR. Okay, and so our total organic carbon can be measured using NDIR. Okay, so the one technique is AAS, that is atomic absorption spectrophotometer, which flame is best suited for analytes with high affinity to oxygen. And you have four options here. Okay, Venkateshwara gave me A answer. But yes, someone gave me B. Pradeep gave me B. So this is N2O acetyl flame that we will use whenever our parameter or our analytes have the high affinity with oxygen. Let me show you first what do you mean by AAS. So AAS is, we will have first light source, and then we do have the sample, and we have to burn that sample so that it can be atomized, it can give you the atoms. Okay, so we need some burner, atomizer burner, that will burn our sample, that will convert that sample into some atoms. And whenever light will go through from that sample, light will be absorbed, right? And this is how, based on that absorbance, you can tell the concentration of particular sample. But you have to use particular wavelength, right? So, and for that burner you have to have different kind of flame for different kind of sample. So if your sample have affinity with oxygen, then you have to use air acetylene, uh, acetylene flame. Okay. Okay, if we want to measure volatile solid, then okay, now here we are moving to solid waste, or you can say the soil. So in soil or in solid waste, we do have different kind of parameter. Uh, for example, volatile solid, suspended solid. So such kind of parameter we also have to measure. So here we do have volatile solid, and in that determination, the residue obtained after drying at 105 degrees Celsius is ignited in muffle furnace at what temperature? So Mithur and Venkateshwar, someone is giving me. Okay, so we have C and D answer, but C is the right. That is the 550. So just see here. What do you mean by volatile solid, and how we can calculate that volatile solid? So volatile solid can be calculated. So A is weight of residue. So after burning our solid, so there will be the weight of residue plus dish before ignition, and B is the weight of residue plus dish or filter after ignition. So one is before ignition, and another is, so one is before burning or another is after burning. So the difference between these two, divide by the sample volume, multiply by 1000, that will give you the volatile solid. But here you have to see, ignition will be happened at temperature 550 degrees Celsius, right? Okay, if we want to determine total solid, so at what temperature we have to dry this total solids? So I'm getting C answer from everyone. So yes, so we have to give 105 degrees Celsius temperature so that it can be dried. And just see here the formula for this. Based on that formula, you can calculate, you can solve some numerical question also. So total solid will be equal to weight of dried residue plus dish minus weight of dish, and upon sample volume multiply by 1000. This is how you can calculate total solid. So this is determined by drying the sample at 105 degrees Celsius in hot air oven till it attain the constant weight. So I will just give 5 minutes on this solid waste and soil. So first we do have to do the categorization. So for that categorization, we do the proximate and ultimate analysis. In proximate analysis, we will have like bulk density. If we want to measure the bulk density of that solid, this will come under proximate. If we want to do the ultimate analysis, so ultimate analysis is uh, uh, how much C and sulfur, oxygen we may have in the solid waste. So that will come under ultimate analysis. We also need to know the fusing point of ash we have in the solid waste. But why we are doing this? Why we are categorizing the solid waste? So that we can dispose this solid waste with our best efficiency and in a sustainable manner. Then we also have to see whether our solid waste can be degraded easy or not. So this we have to see by determining the lignocellulosic composition. Whenever we will have more lignin, means it will be very difficult for us to degrade that solid waste, right? Then we have to see the leaching property, up to at what height it can go down or percolate in the soil. So we also have to see the leaching property and more. So how much, and whenever we are doing the combustion, or we are just burning it in the absence of oxygen or with the presence of oxygen, so how much energy the solid waste can give to us. So such kind of property we need to know, and we must uh, know the method how we can measure that, right? So again, if we are talking about the sampling of your solid waste or soil, then we do have four type of sampling: random, systematic, stratified, and quaternary. And in that equation, there is the one definition of that particular sampling that you have to tell me. So which sampling method involves dividing the study area into non-overlapping sub areas with similar characteristics to ensure uniform coverage? So that will come under what kind of sampling? Mithur gave me C answer, that is stratified. Yes. So answer will be C. Let me show you like different sampling. So random means randomly we are collecting the sample. The one of this random sampling is the zigzag. In the, if even if in the zigzag manner we are collecting the sample, that will also will come under the random zigzag sampling. Then another is stratified. So stratified will be you have to divide your total area into some quadrants, and so that from each of the area you have some representative samples. So this will come under stratified. And systematic is very systematically you are collecting the sample. And quartering is first you have the sample, then you have to mix it, then the diagonally you will mix that, then again you will uh, use that diagonal and you will mix that, and this is how you are collecting the sample. So this will be the quartering. Okay, because we are talking about we were talking about the ultimate analysis and proximate analysis. So uh, the density is a part of proximate analysis, and you have to tell me, we do have different type of density, but the density in which we include both pore volume and interspace, interparticle space, which its value changes with the degree of compaction. So method gave me C answer. So yes, so this is bulk density. So we do have different type of density: absolute, envelope, and then bulk density. You can read about this because some will include volume, volume of pore, some will exclude. So based on that, we can determine different kind of density. Okay, in proximate analysis of solid waste, which parameter is determined by subtracting the percentage of moisture, volatile matter, and ash from 100? So this will be fixed carbon. So here you can just see like moisture. Whenever you need to calculate the moisture, so this will be whenever you are drying at 105 degrees Celsius. Then volatile, whenever you are doing igniting at 90 degrees Celsius, then ash whatever will be remained after your volatile matter has been gone, and then your some of the matter will be uh, will undergo under combustion, and then fixed carbon you can calculate 100 minus moisture, volatile matter, and ash. This is the numerical question just on these kind of things. And I think based on, let me show you. So moisture is initial mass minus dried mass upon initial mass. Then volatile mass is dry mass minus residual upon initial, and ash is final residue mass upon initial mass, and Fc fixed carbon is 100 minus moisture plus Vm plus ash. So this is how you can calculate or you can solve this numerical using that very simple formulas. As I told you, ultimate analysis is uh, we are calculating the concentration of CHNS, right, from the solid waste. So in the presence of oxygen, if we are having the temperature of 990 degrees Celsius, then nitrogen will convert into N2 or nitric oxide. So you can read about this. We have one question: what do you mean by fusing point of ash? So this is the temperature at which ash forms a solid clinker by fusion and agglomeration. And we do have different type of temperature, and this oxidation temperature is not the part of ash melting temperature. And that's how I finish into 2 hour 1 minute. And thank you so much. If you have any problem or suggestion, you